Hello everyone, I am Sivaramakrishna, Faculty of Electronics and Communication Engineering. Welcome to the lecture series on IC applications. Today we will introduce the ICs, the concept of integrated circuits, such as we are going to discuss, we will present the overview of the integrated circuits, which includes the basic definition, what is IC in general, why it is called IC, what it consists of, and when it starts emerging into the market. We will discuss these basic concepts starting from the overview, and then importance of IC in the market. That means in the current technology, what is the significance of IC? Can't we live without an IC nowadays? Let us see. So that these are the things comes under the history of ICs. And further, we are going to discuss the basic concepts. So first we are going to start the discussion with definition. That is, what is meant by an IC? And then we are going to talk about the history of IC. So when the first IC comes into the market, who invent or who find this particular IC? This is a phenomena actually. IC is nothing but a circuit. Who find this one and how it emerged into the market? And then we are going to start discussing the components. What are the basic components present in this integrated circuit? So if you observe integrated, so what is meant integrated actually? It is a circuit. We can broadly divide this single term into two multiple terms, such as integrated and then the circuit. So as any other electronic circuit or pulse circuit, this is also a circuit. What it consists of? It is integration of several components. What are the components here? So you may assume the basic silicon components, such as it can be the transistor, and once again in the transistor, which transistor is used to design the integrated circuit. And if you observe, there are many types of ICs actually, many types of transistors available in the market. Starting from the BJT, that is a bipolar junction transistor, to junction field effect transistor. So again, in FET we have different types, right? So JFET, MOSFET. So we are going to quickly recap all these things. What are the components associated? That means what are the components present in this integrated circuit as a single IC? That we are going to see. And what about the basic components of resistor and capacitor? So one cannot imagine resistor and capacitor. One cannot imagine any circuit without assuming a resistor or a capacitor. So long back, whenever we find a basic circuit using the diode, so to determine the characteristics of the diode, so let us assume this is the basic circuit. So if you want to determine the characteristics of the diode, what is required here? Is it enough to have a single diode? No, we need the resistor, because you are going to pass some supply, right? So what is the role of this capacitor and resistor in the design of your integrated circuit? So this we are going to quickly recap all these basic stuffs actually. And then if you observe, so once we introduce the integrated circuit, starting from the definition and the history and what it consists of. nothing but the basic components present in the integrated circuit, and one must curious to know about different types of ICs in the market. Is it only one type, or is it two type, or any other? How many types of ICs are there in the market in the design process? So I cannot say this is a design, this is a fabrication. In fact, IC is fabricated by integrating several components. It can be a group of transistors, it can be 2 transistors, 10 transistors, 100 transistors, and 1000, and that depends on the requirement actually. So that enrich the complexity of the IC. How many number of components we are going to integrate in it? We will talk about it. So before we go into more details of it, we are going to discuss the basic classification of integrated circuits. So we can say that digital ICs, analog ICs, and then mixed signal ICs. So these things we are going to discuss, and we conclude the session with packaging. So once we fabricate an IC, what is required then? How we are going to pack? So we said in the beginning, we said it is integration of several components. The components can be multiple transistors. It can be more than one transistor, more than 100 transistors. Thousands of transistors are going to be integrated on a single platform. Now the question is how to perform the package. What is the package? Suppose you went to the market, you made a shopping, and you purchased several items actually. And then what is required? How you are going to pack all these items to reach the destination safely without damaging any purchased item. Without damaging any purchased item, we want to ship all these items safely to the destination. So care must be taken while packing of any item, right? So similarly, IC, what is an IC? We said it is integration of IC. It is not one circuit. It is a group of circuits. It is going to be the group of circuits. It has, who knows, we are going to integrate millions of transistors on a single platform to achieve a complex task, to achieve a complex operation. We want to integrate everything. We did that. Fabrication is done. Is nothing but design process is done. And the next process is going to be the package. So package is nothing but how we are going to find the IC in the market. So do remember, IC consists of integration of several components in a single platform, and it is required to pack all these components properly. What are the ways? How can we get an IC finally? How can we get an IC? That depends on the types of package. So in the market, there are several types of packages that we are going to brief in this session actually. Okay, and then if you observe the applications. So finally, if we design anything, we want to achieve something out of it. So what are the applications of integrated circuits? Are they too old? Are they fit for the modern days? Are they fit for the modern applications? In the recent, what we can say, we are in a high-speed technology era actually. So you can imagine technology is evolving every day. It is not by month or by year actually. New products are coming into the market. How these ICs are going to address? How these ICs are useful in this days actually? Are they find any applications in the recent days or not? So this is another interesting component. We need to find the applications. So no matter how complex circuit we are going to design and how many thousands and millions of transistors are incorporated on a single platform, then what is required? How we are going to use it? Where this particular IC is useful? Unless the designed or fabricated IC finds its applications, it is of no use. So that's what the recent technology talks actually. Whatever the technology we come up, whatever the technology we design, finally it should meet its some applications. We need to address some kind of applications. So that is utmost important in any technology. In any technology, what is required here is what are the applications, where these ICs are useful, where we are going to use these ICs. So that we are going to brief here. So in the due course, we are going to talk about everything in an elaborated manner. We are going to elaborate everything. All the topics will be elaborated. And here we are going to throw some applications of these ICs. So with this, we can conclude this session. Now coming to the overview of the ICs, if you observe IC, what it stands for. So I said it is a combination of two words actually, where I stands for integrated. I stands for integrated and C as usual stands for circuit. So let me recap the well-versed amplifier, that is a common emitter amplifier. What is common emitter amplifier basically? So we can say that it is amplifier to amplify the signal. So what it will do? It will basically amplify the signal strength. So that is objective. I am receiving a poor signal or weak signal having a strength of some millivolts. I want to enhance this to at least to some volts, at least 1 volt or 2 volt, right? So how can we achieve this one? This is a task. So what is required here? I need to come up with a standard circuit. What is that circuit actually? It can be a BJT based amplified circuit. I can design a BJT based amplified circuit. Also I can design a FET based amplified circuit. It can be a FET based amplified circuit. So again, if you recollect, it is a circuit having three configurations. It can be a CE, it can be a CB, it can be your CC configuration. So what does it mean? So it is a simple amplifier circuit. It is an amplified circuit, can be designed using common emitter mode, common collector mode, or it can be your common configuration, common base configuration mode. Similarly, if you want to design a FET amplifier circuit, how can we design this circuit? You can come up with common source and you can come up with common drain. You can design common gate. You can come up with a common gate. Of course, each amplifier finds some advantages as well as disadvantages. That purely depends on the applications where you want to use this particular amplified circuit. So why we are talking about the amplifiers here? Is it a non-sync to this concept? Not at all. Because we are going to say that IC, their IC stands for integrated circuit. So look at the second letter. Second letter stands for, so what is the second letter? It stands for the circuit. It stands for a circuit. So now I want to talk about the circuit. What is meant by a circuit? So we know that a basic amplifier, it can be common emitter configuration mode, common base mode, common collector mode. If you come to the FET based amplified circuit, it can be your common source, common gate and common drain, right? What are all these things? They are fundamentally circuits. They are fundamentally some circuits. And similarly, let us go back to the digital circuits. So what are the digital circuits? One can notice. So you may realize an adder. So let me talk about the adder circuit. Or it can be a subtractor. So what are these circuits? These things actually, these are again circuits to meet or to perform a specific application. So if you design an adder, what it will do? It can perform addition of 2-bit data or 3-bit data, whatever it may be. Addition, it basically performs addition operation. Receives some binary data and starts performing the addition. And again, if you go in depth, you will notice You may say, I have a full adder, I have half adder, like that you can come up. What are all these things basically? Again, digital circuits. And similarly, subtractor, what it will do, it will get the binary data and perform subtraction operation. Again, you can say that it is a half subtractor or it can be a full subtractor. So what are all these things? These are some standard examples. One can say that these are basically circuits. These are nothing but circuits to meet some application. Right, up to this we are very clear. So in IC, we are very clear with the circuit. What is a circuit here? It is a circuit to perform some standard application, some standard task. Right, and let me go back to the amplifier once again. So we said common emitter, common base and common collector amplifiers. To design these amplifiers, what are basic components are required? So one should know in advance. We should know in advance. Before you start designing any circuit, you must know what are the components required. So let us consider a common emitter amplifier. What are the components required here? So you need a BJT, and you need some number of resistors and you need some number of capacitors are required. And apart from all these things, of course, the bias. Of course, another key parameter, a key component to these circuits is nothing but the bias. We need to provide the bias, right? So anyway, we are going to list some number of components. These are the components required to design this particular circuit, right? Similarly, in the integrated circuits, it is a circuit having different number of components which are integrated. Now you can address the first letter. What is the first letter? Integrated. So what is my circuit? Circuit is basically a group of components. A group of components are going to connect together to meet or to perform a standard application. Now it is going to be I. What is my I here? I stands for integrated. So what is my integrated in fact? So in mathematics you might know about the differentiation. Two mathematical terms you must familiar about it. One is the differentiator, another one is the integrator. So can you remember what is the role of this integrator? What it will do? It is basically to integrate. So where we use this integrated component or operator in mathematics, suppose you are asked to perform some area. You are asked to perform area of a curve or the existence of the curve over which period. It is always recommended to use the mathematical component called integrated. Right? From which time instant to which time instant the signal do exist. So that we can say that the area of the signal usually. Right? So how can you compute the area of the signal here? We basically consider this integrator. So suppose I want to find the area between 0 to 2 pi. I need to integrate over this range. I need to integrate over 0 to 2 pi radians of the signal, whatever the signal. It may be a sine or cosine or tan, whatever it may be. Right? Integrator. So you can bring the same terminology here. Here integrated means integration of several components. Integration of several components. So we are going to design a circuit with several number of components, and these components are integrated. That means connected together. They will come together on a single platform. That is nothing but an IC. So later if you ask me what is my full adder, I will present an IC. That IC stands for, I can say, adder circuit. It will perform addition of 2-bit data or addition of 4-bit data, I can say. So what are all the components required to perform this particular addition operation are all integrated on a single platform. All these components are come together come together to meet or to find this particular application is called an IC. So this is one thing. And what about the size of this IC? We said we can design any circuit, and we have given an example for amplified circuit, and we have given an example for added circuit. The biggest worrying point here is going to be the dimension or size. They are obviously small in size. That's why it is a miniature of the electronic circuit, miniature electronic circuit made up of several components such as transistors, resistors, capacitors, all are integrated onto a single semiconductor chip. Chip is nothing but a platform. I will tell you that. This is a terminology. So before you start learning any subject, better familiarize with the basic terminology. That will assist you better while enriching the knowledge towards that particular subject. Right? And now, so look at the integrated circuits. We further continue the overview of this integrated circuits. So what we can say, it's a miniature electronic circuit integrated integration of several components on a single platform. That is called IC, a chip we said. Right? Now see here. See, these integrated circuits are usually referred as IC, are usually referred as IC or microchips. Micro stands for the dimension or its nature. It is a very small in size, and are electronic components that are made up of multiple interconnected semiconductor devices. So what is there inside the IC? What is there inside the microchip? It is going to have the integration of several components. It is going to have integration of several components and other electronic components, such as it can be a resistor, capacitor and inductor, basic components. So these interconnected devices are fabricated on a single platform, nothing but a single piece of material, typically a silicon or a germanium. Usually we can say that any semiconductor device can come up with the material such as silicon or germanium material. So finally, so this is an IC we said. This is an IC. So having integration of several components. What are the components we said? It can be a transistor, resistor and then capacitor, of course the inductor. All these are integrated on a single platform we said. And you must know what is the objective of this particular integration. What we are going to achieve, what we are going to perform with this kind of integration. So what we are going to do here, some application. We said amplification. We said amplification of the signal. So what it will do? It will enhance the signal strength. So to meet this particular application, I come up with an IC. So instead of considering all the components discretely and putting them inside a breadboard and interconnecting all these components is a so much tedious project actually. It is going to be very complex in nature. To address all these things, let us come up with an IC, fabricate everything on a single platform, come up with a single and miniature electronic circuit to meet the required application, to find this particular application. So now what is meant by the IC we have seen? IC is nothing but the integrated circuit. So what it consists of? Several components. What are the components? It can be your transistor, resistor, capacitor, inductor. All these are integrated on a single piece, are integrated on a single chip, nothing but an IC, right? And now if you move further, we can see how they are going to revolutionize the technology. So can you imagine any technology without any IC, without an IC? So can you imagine any PC or laptop without an IC? Can you imagine a motherboard of your personal computer without an IC? I will say no. I will strictly say that it is Absolutely no. It is very hard to imagine any technology or any any product without an IC. Without an IC. So even if you come up with a 4K audio video system having high resolution and quality audio, quality video, do you think these gadgets or components are designed without IC? No, not at all. They must consist of these ICs. That's why we can say they are going to revolutionize modern technology. Revolutionize modern technology, making it possible to pack more functionality. More functionality. For simplification, we said amplifier as a circuit. So there are many number of functionalities that a single IC can perform. So just imagine the nature of the motherboard in early 90s, the nature of the motherboard in early 2000s, and the nature of the motherboard in 2010s and the nature of the motherboard in 2020s. Are they going to perform the similar functionality? Are they going to work with the similar functionality? Answer is once again no, because the nature of the processor that we use in the design of your personal computer is going to equip with several uh, technology is going to perform several functionality. So it can be a graphic design, or it can be a gaming system, or it can perform high-end data analysis, or it is to run a complex algorithm, build a complex structure, run a complex code in quick time. All these are the functionalities. So it is not only the speed of the processor. Also, it equipped with several latest technology. So what is the meaning of this one here? The modern technology gadgets cannot be imagined without IC. It is not possible because the single IC is going to perform several functionality. It is all about the design or fabrication of your IC, how you are going to design your IC. You can design an IC for one operation, or you can design an IC to perform 10 number of operations, or you can design an IC to perform 1000 number of operations. It all depends on the components that we use in the fabrication of your IC. So that's what the Moore's law, we will tell about it actually. So we will talk about the Moore's law later. So it is all about the integration of the components. How many components we are going to integrate? Are there 2 transistors, 10 transistors, hundreds or thousands or million number of transistors? So the single IC may perform multiple functions. That's what the meaning of this actually. And they enable the development of faster and more powerful computers, smartphones, medical devices, and many other electronic products. So where we can use all these things, where we can use these ICs. These are very few, which we are going to quote here in this presentation are very few in fact. They are endless. There are many other applications you can find. These are very frequently used areas where you can find these ICs. And then coming to the history. So history is very, very important. So where you start this IC? How do you know this IC? So you must say the starting point of your IC. When it comes actually, when it originates, where it originates. So if you remember, we have set of flip-flops in digital circuits. What are the flip-flops we have? So there are like SR, JK, T flip-flop and D flip-flop. So highlight this JK. Do you know the full form of JK? How it is going to be? It becomes JK. So you know, yes, SR usually people believe that is a set and reset kind of flip-flop. T is nothing but a toggle flip-flop, and D stands for a data flip-flop. So anyway, we are not going to discuss these flip-flops right now. I will give the justification why we are going to talk about this flip-flops here. It is not a non-sync once again. See, highlight this JK, where JK stands for Jack Kilby is a researcher from Texas Instruments who finds the, the miniature IC, who designed this miniature IC in the year 1958. So we can say that that is the origin of an IC, and the credit goes to the first researcher who find this phenomena, integration of components, integration of several components on a single platform. That is nothing but a chip. So do remember, in the year 1958 by Jack Kilby from Texas Instruments, that is the history of IC. And the next year, so the another one famous scientist Robert from semiconductor, so independently invented a similar technology using silicon, which which allows the people to come up with a new ICs actually. So you can always remember these two people who are the pioneers of this IC technology. So Jack Kilby's first IC is a motivation for integrated circuits, and then Robert, so who find this particular IC in the next year actually. So this is the history of the IC, and of course since then there is a rapid growth. Since then there is a rapid movement in the IC technology. There are several and thousands of ICs in different types of ICs are emerged in the technology in the market. So they are very powerful and they are very high speed ICs in fact. So and then coming to the definition, whatever we said so far, the definition of IC is there itself, integrated circuit. So what is by integrated circuit? You always split this single sentence into two, integrated and then circuit. So you know about the circuit. Circuit is a group of some components. Group of some components. You don't think it is a discrete component. So circuit requires a discrete components, a set of discrete components which are placed on a breadboard and requires to be integrated, requires to be connected. So what is my integrated circuit here? See, commonly referred as IC. So that's why you people can remember. Integrated circuit can be remembered as a IC. So our electronic components, ICs are basically electronic components that are made up of multiple interconnected semiconductor devices. So what IC is here? So it is basically electronic component. It is basically electronic component. So that are made up of multiple interconnected semiconductor devices. So what are semiconductor devices? You can see transistor here. We are going to fabricate the IC with the help of the transistors here. Such as we can say transistors here. We should say here transistors. Of course, these inductors, resistors and capacitors are also designed with the help of the transistors itself. So if you remember the RTL logic, DTL logic, so that is a basic design of any digital circuit. So later we have ECL component, ECL kind of emitter coupled technology. Emitter coupled technology we have to, and then we have CMOS technology to design all these digital circuits. So why I'm talking about this means all these basic resistors, inductors, capacitors can be realized using transistors itself. So these interconnected devices are fabricated on a single thin piece. Here we are going to integrate all these components on a single thin piece of semiconductor material, typically silicon, which are designed to perform a specific function or some function set of functions. So this we can say as the definition of an IC. So once you understand the basic concept of IC, you can come up with your own terminology. You can come up with your own sentences. So what is IC here? It consists of integrated circuits. So what circuits here? The circuits that are designed by using semiconductor components to meet a specific function or set of functions which are integrated on a single platform. Nothing but a semiconductor material. So this is nothing but the definition of what we can say integrated circuits. So further, if you investigate more about the IC, you can see that the process of fabricating these ICs. So that means how we are going to integrate these semiconductor devices to find a specific application on a single platform. This complete process is nothing but a fabrication of ICs. So these interact on a single conductor material is known as a IC fabrication. IC fabrication is again another end of the technology, we can say. So here we are not going to talk about the fabrication of ICs. We are going to talk about different types of ICs. Fabrication of ICs can be discussed under the subject called VLSI technology. There the subject completely talks about the fabrication of ICs, how to design the ICs. Now, see, we said semiconductor devices. What are the semiconductor devices we are going to consider? We said transistors. We are going to consider the transistor. I want to talk about the basic transistorized circuit here. So what ICs consist of? Transistors. Transistors are the basic components here. So how we are going to use these transistors? Having some multiple number of transistors and integrating them and connecting them using a single copper wire? No. These transistors should be designed in the form of a specific circuit. What circuit it is? It is going to be an amplifier. Transistorized amplifier circuit we are going to consider. I am going to talk about the very basic IC. What it consists of? It consists of amplifiers only. The basic IC itself consists of an amplifier. And once again, which amplifier we are going to consider here? So we can classify the amplifiers into several, right? So there are different types of amplifiers available in the circuit technology. In the circuit technology, there are different types of amplifiers are available. Which amplifier we are going to use? The answer is going to be the differential amplifier. So which amplifier we are going to use here? Differential amplifier. So the transistors that we use in the IC are connected in the form of differential amplifier. So we will talk about differential amplifiers in the next lecture. In fact, there is a vast amount of discussion on a differential amplifier. What is differential amplifier? What are different types of differential amplifiers? All these things we are going to discuss. So up to now you can remember IC uses semiconductor devices. Semiconductor circuits are supposed to be the transistors. Integrated circuit consists of number of transistors. But how these transistors are arranged or available in IC are nothing but amplifier. The nature of transistors used in this means how they are going to perform means it is going to be differential amplifier. They are going to perform a differential amplifier kind of task here, right? And coming to the functions, yeah, of course, the functionality of this particular IC, basic IC, which I am going to talk is supposed to be the differential amplifier. So we will talk about it later in the next class. And now coming to the classification of ICs. So it is fine. We have defined the IC. What is meant by IC we define. And then coming to the history starting from the year 1958. Finding the motivation from Jack Kilby and then coming up with latest and modern ICs. Today it becomes a huge demanding subject in the technology, and without IC there is no electronic component. We said all these things. And what an IC consists of? It consists of integrated components. All these components are integrated together on a single platform called a semiconductor material. And we said it consists of transistors in differential amplifier mode. Fine. What is the classification? How many types of ICs available in the market? broadly there are two types. One is going to be the analog IC and other is going to be the digital IC. So what are analog ICs? They work with some composite signals, and the best example is going to be the operational amplifier. We will discuss and we will talk about it later. And then digital IC, obviously the term spells or uses digital. So what kind of signals? See, any signal you design, it is all about the signal. So you need to input some signal and you need to get some signal as the output. It is all about the signal processing. What is your input and what is your output here? So we can say that there are two types of signals. It can be your analog signal or it can be your digital signal. So analog ICs basically come up with this kind of analog signals. Their operation is limited to a kind of analog signals. To some extent, they can go with the digital signal also. While discussing operational amplifier and its applications, we will talk about these things actually. And digital ICs, they purely work with digital signals only. And the best example is nothing but any digital circuit. So what are the digital circuits here? We can say multiplexer, demultiplexer, and we can have encoder, decoder circuits, and then register circuits, and then you can come up with the flip-flop. So what are all these things? Are they analog or digital? They are purely digital because the entire signal processing is all about the digital. They take some digital input and they respond. They respond to your digital input digitally. They respond to your digital input digitally. They produce digital output only. So these are some examples we are going to talk about it. And of course, we are going to talk about the complex ICs, what it is going to have and what is the nature of this IC, how it looks. That is the curious about it actually, right? We are very curious to know about how it looks because you know about the transistor. You may say that it has 3 terminals. You know about the diode. You may say that it has 2 terminals. Right? How the IC looks, that we will present here. So before we present the nature of the IC, that means how it looks. So you can see that. So these integrated circuits can be further classified into different types. The entire ICs, they are of monolithic circuits and thick film circuits, thin film circuits, and hybrid circuits. And further, monolithic circuits are basically from bipolar and unipolar transistors. And you know about the bipolar, it can be your PN junction or dielectric, and unipolar, it can be your MOSFET or FET. This is the most useful and having number of applications in the market. Almost all the ICs are fabricated using mass technology only. So, and now let us look at the shape, how it looks like actually. Nothing but the packaging. I'm going to talk about the packaging. We fabricate an IC with several number of components, that is 1000 number of transistors. Now packaging. Packaging is the final outlook of any IC, how it looks like. So right, it purely depends on the way you are going to perform packaging. There are 3 types of packaging available. One is the metal can type, dual inline, and another one is a flat pack. So whatever you can notice here, this is a best example for the metal can type. It looks very similar to your transistor. So this here we have a cap, here we have a metal can cap, and you can find some number of pins that comes out from the metal can type. So this is how metal can IC looks, and it's a flat view. It's a flat view actually. Now see the DIP, dual inline package. So these are the examples how they looks like. So in a dual inline package, so everything is fabricated as a within this IC, and these are the pins. We can say that pin 1, pin 2, 3 and 4. And similarly on the other side also you are going to have 4 number of pins. So this is an 8-pin IC. In fact, this is an example for 8-pin IC. So which is a dual inline package, and of course this is its cross sectional view, how it visualize, right? This is the package, and which is available in the market, and this represents an IC of 8 pin. This represents an IC of 8 pins. And the third one is going to the flat pack type. So here, this is the example for a flat pack type IC. So all the components are integrated on a flat pack, and unlike a dual in pin package, dip package, so you can see the terminals coming out horizontally, expanded horizontally. Again, this has how many number of pins here? So we can say that 3, 6, 8 number of pins are available here. So this is how the flat pack type IC. This is flat pack type IC, how it finds, and this is how it looks actually. This is how it cross sectional. This is the cross sectional view of the flat pack type. So these are the basic packaging types. So packaging types are nothing but how will you find the IC in the market, how it looks. It all depends on the packaging type. We have metal can type, dual inline, and then we have a flat pack type. How it appears in the market, how it is visible, nothing but the packaging. So in this lecture we have seen the basic overview of IC, nothing but the introduction, and then the history we have seen, and the basic definition, and then we have seen what is there inside the IC. We said nothing but transistors, and then about the packaging we have seen. Packaging is nothing but how the IC is available physically. So with this I conclude this session, and we continue in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.